Hello.
Yes, sir, I think we can start the session now.
Okay. I think we have sufficient number of people over here, so I am sharing my screen.
Okay, sure, sir. Go ahead.
Okay. Yeah. Hi all. A very good evening to you all present in this session. And in this session for the day one of the week one, we'll be starting with the descriptive statistics. Right. So statistics can be divided into two parts. One is the descriptive statistics, the other is the inferential statistics. In descriptive statistics, what we do is we look into the data and see what are the describing parameters which describe my data, as like how is my data looking like, how are my data distributed, are those skewed or are those right-tailed or are those normally distributed. So all those questions and all, before deep diving into any of the model building or deep diving into any of the case study what we have and plan to use our data for, what we as a data scientist or as a data professional, what we need to do is we need to look into data and get a basic understanding of the data first, and then we can start our other practices and other modeling things and all as per the expectation. So this is the agenda for today, a pretty long agenda. So we'll be starting with EDA and what is EDA and the Python libraries which are required for EDA. And then we'll be deep diving into the descriptive statistics, the basic descriptive statistics, that is the mean, median, mode, variance, standard deviation, percentiles, quartiles, and then we'll also be looking into the various data distributions which are there. And then we will be looking into data summarization as how to summarize my data using the tools which are available like with pandas. And then we'll go with data cleansing and preparation, how to handle missing values, what are missing values, and how to impute them and how to make them use for good, right? And then we'll be looking into the outliers. So what are outliers, how to deal with outliers, and what are the different mathematical and statistical concepts which are available so that we can deal with outlier. And the other thing is data transformation. So how to transform data from one scale to other scale? Why do we need to do data transformation at all? And the various type of data transformation which are available for both continuous and categorical data. And at the end, we'll be looking into the data visualization. So what are the various data visualization techniques and tools which are available? So like for univariate analysis and bivariate analysis, like the data corresponds with the other data what we have, and also multivariate analysis as also like a group of data and how they are correlated with each other. So all those things will be taking up in today's session. Along with this, I have also some of the codes and walk through examples which are there on the go. I can also share them with you as and when the time is perfect. Okay. Yeah. So introduction to EDA. So what is EDA, right? So EDA or exploratory data analysis is a crucial step in data science that involves summarizing and visualizing the main characteristics of a data set. The goal of the EDA is to gain insights and understanding of the data before proceeding to more formal modeling and hypothesis testing. So as I mentioned, like EDA is one of the crucial steps in any of the data uh, preparation journey. Maybe that would be say any of the basic to basic data analysis stuff to advanced data manipulation or model building stuff. So prior to that, we need to do the EDA and get a deeper understanding of the data. So what are the various Python libraries which we can use for EDA? So for the particular session, we are only sticking to Python libraries, and we would not be deviating from here, given that most of the as a professional, we mostly stick to Python, and most of the tools and resources which are also open source and openly available are in Python. So we'll be using the mostly available users resources, that is pandas, numpy, matplotlib, seaborn, and plotly. So pandas is basically to manipulate data and creation of data as on a data frame, and NumPy is for the data array type transformation, all those manipulations and tools and techniques which are there for array type. And similarly, matplotlib, seaborn, and plotly are there for plotting the data and visualizing the data. So plotly is more of a interactive kind of a tool or a dashboard wherein you can plot your data, zoom in, zoom out, do all those interactive operations which are not possible with the cases of matplotlib and seaborn. So coming to descriptive statistics, one of the most common descriptive statistics which we already, like most of us have heard about, is the mean or the average, right? So what is mean? So mean or the average is the measure of the central tendency that summarizes a set of numbers by identifying the central point within the data set. So this is nothing but if we have a particular array of numbers, that means a set of numbers what we have. So what is the central point of the data if we don't arrange it symmetrically and just take the weighted average of all the numbers? That means if I do a sum of all the numbers, say starting from the 0th index to the nth index, suppose there are two numbers 0, 1, 2, 3, 4, 5, 6. I want to find the median. So I want to find the mean or the average of it. So what I do is I take all those numbers and I don't have to arrange it symmetrically or in any fashion like ascending or descending order. I just have to sum all those numbers and take out the division by the total number of data points which are there in that particular array. So 0, 1, 2, 3, 4, 5, 6. So these are the set of seven numbers. So 0 plus 1 plus 2 plus 3, 4, 5 plus 6 by 7. That would give me the median, sorry, that would give me the mean or the average of the particular data. So the mean provides a single value that represents the center of the data distribution. Okay. I will be showing you some of the data points and also asking you as which is the mean, which is the median, and which is the mode, and also why we need to find out each of those data points, even if like both refer to the same thing. Okay. So median. So what is median? So median is also the measure of a central tendency of the data. Unlike the mean, in the median, what we do is we need to arrange the data in an ascending or the descending order. So mind this thing. So it needs to be in a ascending fashion or a descending fashion. And unlike the mean, the median is never affected by extreme values. So extreme values, I mean any outliers which are there within the data. So this I will be showing you within the through an example, which will be much more meaningful for you. In that case, we generally prefer for median as compared to the mean. And the mode, the third central tendency which we generally use and mostly use to find out the occurrence of a data is the mode. So mode is a measure of the central tendency that represents the most frequently occurring value in a data set. So in cases like where mean and median doesn't tell about my underlying data distribution, there we need to go with the mode. So mode, in other words, is if we arrange all those values and take out how many times each of the particular data each of the time the data point is occurring in that particular data set, the frequency of occurrence is told by mode. Okay. And the other thing is the variance and the standard distribution, standard deviation. So what is variance? From the data point, we already know that which is my mean of the particular data. So variance is a statistical measure that quantifies the spread or the dispersion of a set of data points around the mean. So if I have a particular data set and I want to know like from my mean, how are my data points deviating from the mean? Like how much are they far away from the mean? Are they really close to my mean, to the average, or are they away from the average? So to understand that, the what people had or mathematician had come up with was variance. So variance, a higher variance indicates that the data points are more spread out from the mean, while a lower variance means that they are closer to the mean. Okay, and this is the formula for the variance. So variance, what we do is sum of the xi minus x bar. So x bar was our original average or the mean. So from mean, how does each of my data points, xi is the individual data point in my data set. How does each of my individual data point is deviating from the mean? And we take a square of it and the sum of all these square differences by the total number of data points which are there in the data. That gives us the variance. So you would say, like, if you have got the variance, then what is the need of the standard deviation, right? So the basic difference between variance and the standard distribution is, in standard deviation, what we do is we just take a square root of the variance. This was the same formula for variance. And for the same formula, what we have done is we have taken a square root on top of it. So how does taking a square root of this thing would help us, right? Suppose say all of my data points are in meter, right? So that would say that how far are each of the trees which are planted in a row are deviating from the mean or the average. So each of the data points would show that how many meter are they away from each other, right? So if I take a variance of that, so that would give me the square in terms of square number, which might not be possible for me because a meter square might not be meaningful for me. So to take into the original uh, original measurement unit, what we do is we take a square root of the variance and from that we take the standard deviation. So standard deviation is mostly useful in case like where we want interpretation and we are much more uh, conscious about the unit of the measurement. So I will lot of lectures. So in the meantime, I'll show you like how can we do all those things in Python, and also I'll be asking you questions in and around on what are the individual values of that. So keep your pen and paper ready, and you can post them in the chat box. Okay. You guys can see my screen, right? Hello.
Yes, sir, your screen is visible.
Yes. Yes.
Okay. 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 So I can see the chat box. Is that disabled for me?
I think, sir, you can see the chat box. It
Can
will be
anybody
visible to you.
ping hi over there? Okay, anyway, so like I would expect like people on the call or on the uh, if they don't have access to the chatbot, they can also raise their hands and also let me know and switch on their corresponding microphones and let me know. So these are the necessary libraries which we need to do for basic descriptive analysis. So suppose that this is what the data set what we have, right? Our data set is the set of points, say 5, 2, 3, 4, 7, 1, 6, 1, and 1000. Okay. So can anybody like tell me what would be the a ballpark mean of this or the average of this? Hello. Hello.
Hello.
Yeah.
Yes, sir, your voice is clear.
Yeah.
We can
Can
hear.
anybody tell me what would be the average of these all numbers if I take if I have the set of numbers 5, 2, 3, 4, 7, and this? Anybody like can take a hit? Like,
So
will that be
114 something.
okay? So how you came up?
I calculated the mean. I added all of these given elements in the array, and then I
Mm-hmm.
divided it by the frequency.
Okay, okay. So it was something 114, right?
114 something.
Okay, okay. And what would be the median of this? How to calculate the median? Can anybody say me? As we already took that up in the lecture also. How to calculate the median?
Arrange it in the ascending order or
Sir,
descending order
first
and
we need to,
solve.
sir, first we need to sort the array in ascending order. Then
Okay,
we need to take the middlemost value. If
okay, okay,
the number of digits, if the number of elements is odd, and if it is
okay,
even, then we need to take the two median value and divide by two.
okay, 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 okay. Got it. Got it. Okay, okay. Yeah. So someone said it would be near to 114, and someone said that the median would be if we arrange it in the ascending order, then and take the middlemost value, we will be getting the median. Okay. So I did the same thing using pandas, sorry, using Python and NumPy. And this is what I got the mean of it. So what you need to do is this is the data and this is in a list format. I think most of you would be aware of this particular data structure. So this is how we represent a set of data points in data science in Python. So this is the data point what we have, and this is the data what we have. And let me calculate the mean. So mean is 114. Okay. And median is if I arrange all these numbers in a increasing order, and there is an ascending order, and take the centralmost value which is there, it would give me the median of it. So if I print the median, which is from the numpy, numpy.mean is average and numpy dot median is the median. So my median is coming to be 4. Okay, so one would say that this is 4 and this is 114. So what difference does it give? Okay, so what is the point of taking the mean and what is the point of taking the median? So if you would carefully look into the data what I have, so this is the set of numbers what I have, and there is a huge number which is there at the end, which is 1000. Okay, so let's say I decrease that 1000 and make it 10. So 10 is within the ranges of 1 to 5, 1 to 7, 1 being the highest and 7 being 1 being the lowest and 7 being the highest. So 10 is within the ranges of this. So what it would give is the mean and the median to be in the same range. So 4 and this is also 4, right? So if I have a huge number or huge outlier within my data, it tries to pull my mean or the average towards it. So if any of the outlier is present within my data, it will try to pull that average value towards it. So if I want to know, like in my class, there are suppose say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 students are there in my class. And this is how they have scored in a particular subject. And just I wanted to give a understanding of how well are my students performing in my class. So if I take a mean of it, it would say that it is near to 14. But in reality, most of the students are falling uh, within this range. They are like 4% of the total value is what my people are scoring. But the mean would give me a highly scaled version or highly abrupt version. So to tackle around that, what we need to take is if we have outliers or if we have data points which are out of scale, so in that case, we need to go with the median. And the other thing is the mode. So mode is the frequency of the occurrence of the any of the data points. So if you see 5 is occurring once, 2 is occurring once, 3 is occurring once, and all of the data points are occurring once. So only 1 is occurring twice. So the mode of my data point is 1. So any of the data points which is occurring more than once, sorry, which is occurring more frequently within the data, that is the mode of the data. So suppose say I have got another 3 in the same data set. So still it would give me as 1 because it also arranges it in an ascending order. First ascending value and which has the highest occurrence. So if I have got another 3 over here, then I think 1 would go away and 3 being occurring 3 times would come up over here. And then coming to the next thing. So variance, right? So this is the original data set what we had. And I just want to understand as how are each of my data points are deviating from the average. So let's say this is 1 and this is my original data set what we have. Okay, and this was my average. So average was 14.22. So I want to understand like how 5 is how much is 5 from 14 and how much is 100 different from 14. So how much is the deviation of my data from the central point? So central point is the 14, right? So how much are my data points deviating from the mean? So to do around that, what I need to calculate is the variance. So if I calculate the variance of the data, it is coming as 923. Okay. So as you can see, my data points are still in the ranges of 5, 2, 3, 1. Suppose these are the
Excuse me,
marks.
sir.
Yeah.
Sorry to
Hello.
interrupt you, but one of our participants had a question. I think Hitesh.
Okay. Hi.
If you have any questions, then you can raise your hand. And after sir explains a concept, then you can ask your question. So if Hitesh, now you have any doubt, then you can ask to sir.
Yeah, Nilesh. Are you there?
Okay,
Okay.
we can
Anyway.
continue. We
Yeah.
can go ahead.
Yeah.
If
So
anybody has any doubts, then they can raise their hand, and after the concept is complete, you can unmute yourself and ask the question.
yeah, so what we were doing is we were calculating the variance of the data. So this is what my data point was, and if I calculate my variance, so this was coming as 923. So if I would say that my data point is 923 points away from the average, so that would not give me a direct inference as how much is my data point away. So 5 is what? How many data points away? So 5 is what? Minimum 8 to 9 data points away from my 14, and similarly 2 is 12 data points away from 14. So but my variance is coming to be a something 923. So this gives me a highly skewed number. So to tackle around that, what we have done is we have taken the standard deviation. So standard deviation is nothing but the square root of the variance. So the same thing I can do is in place of calculating the np dot std or the standard deviation, what I can also do is np dot numpy dot square root of the variance. If I take a print of that, so that is coming the same number as I calculate using the numpy. Okay. So 30.39. So this is that on an average, my data points are 30.39 distant points away from the mean or the average. So 100, given that there is 100 within the data, so that is affecting the data points, and that is playing around with my variance and the standard deviation as well. Okay. Anybody has any questions on this? Okay. Going back to the next topics is the percentiles and the quartiles. So what we have understood
Excuse
on
me.
the data, yeah,
So we one of our participants has raised her hand. Gangotri, if I'm not wrong, then you can ask your question. You can
Hi,
unmute
sir.
yourself. You can unmute yourself and ask the question
Hi,
after his.
sir. I have a doubt. I'm
mm-hmm,
new to data science, and
yeah.
I want to know when do you decide you have to do PD, NP, or stats?
Sorry, you have to do.
Um, when do you decide, like, how do you decide if you have to do NumPy, Panda, or stats?
Yeah.
How do you write the program?
Okay, okay, okay. So the thing is, so pandas is a library which is mostly used for data frame analysis and data frame creation and data frame manipulation and all those crude operations. So data frame is nothing but whatever you see in an Excel format, like a row and column format. That is what is the data frame is. And NumPy is a set of tools which are available. So the same thing, I think you can also, without using any external libraries. So these are the libraries which are available in Python, which makes our thing easier. The same thing what I calculated over here, right? To uh, find the average of the data set, the average of the data what I have. Without using the NumPy also, I can do the same thing as like I can do like data of 0 plus data of 1. That would give me all those values, and similarly data of data of 7, given that I have got 7 data points, and what I can do is the number of values which are there in my data set, so that is 7. So this would give me the average of the data set what I have. So without using these all things as writing my own set of programs in the particular analysis what I am doing, without using this, what people have done is to make life easier for us and people like you, is they have made that into packages. So this is what is package. In NumPy is a particular package, stats is one package, and pandas is one particular package. So within this package, these functionalities are there, like the mean, median, mode, and all those things. So like mode was not available in the NumPy. So for that, we had to go with the stats, right? So all these things are like packages, and based on like usage and all those things. So there are also different libraries which are also available, which are not like developed for other applications, and you can also create your own applications and make that as a library. So it depends on the use case that you have, and mostly it is used to make life easier.
Thank you, sir.
Okay. Yeah, coming back to the percentiles and quartiles. So what is percentile, right? So percentile is a measure used in statistics to indicate the value which a given percentage of observations in a group of observation falls, right? Like say, suppose say I have got a set of data points, and through the median I found out, like on arranging it in an ascending order, I found out that this is my middlemost data in my data point. So I want to understand how much is my 10% of my data looking like, or how much is my 99 percentile of my data looking like in CAT and all those competitive exams which you might have given. So the number which comes is in the percentile. So there might you might have understood that for getting into a particular IIM or getting into a particular university, the particular number that you need to have is 99 percentile or 99.8 percentile, right? Or it need to be more than say 97 percentile. So what is percentile? Why do people go with percentile as compared to the mean or the mode, right? So percentile is nothing but if you arrange your data in an ascending order and take the centralmost data point, which is also known as the second quartile or the Q2. It is the median or the 50th percentile. If I take the centralmost point in my data set, that would be the central Q2 quartile or the median. If I take the 75th percentile of the data, that means if I arrange my data points, suppose there are 75 data points in my data set, and if I arrange them in an increasing order and take the 75th data point, so that 75th data point would give me the 75th percentile. Okay, hope my explanation is clear to you all. In that cases, we go with percentiles and quartiles. So percentile is gives us the numbers or the set of distributions which are there if I arrange my data point in an increasing fashion. And quartiles are nothing but if I arrange my data points into four quarters or the quartiles. So the first quartile is 25th percentile, second quartile is the median or the 50th percentile, and the third quartile is the 75th percentile. Okay. So under the third quartile or 75 percentile, 75% of my data points are lying. And second quartile is below that 50%, above that 50% of my data point lies. And first quartile is below that 25 percentile of my 25% of my data point lies. So let's coming back into this thing as how to calculate percentiles and quartile in my particular data set. Okay. We already have point, right? So this is our data set what we already have. So using np dot percentile, I can calculate the 10th and the 90th percentile. So my 10th, this was how my original data was looking like. Okay. 5, 2, 3, 1, 7, 3, 6, 1, and 100. Okay. So from this data point, I want to know what is my 10th percentile of my data. So the 10th percentile of my data is 1. And a 50th data point, which is also the median of the data, is 3. And the 99th percentile is 92, which is near to, if I arrange all these data points in an increasing fashion, so that would come to 92. Okay. So if I replace this percentile number, so 10, 15, 99 with 25, that would give me the quartiles. So if I print my quartiles, so this is, again, this is how the quartiles are. So my 25th percentile or the first quartile is 2, 50th percentile, median is 3, 76, and the interquartile range. So interquartile range is nothing but the difference between the third quartile and the first quartile, Q3 minus Q1. So this says me as how my data is distributed. So if I take a difference between 6 minus 2, it is coming as okay. So keep this points in mind. So this is going to be helpful for us while we are looking or going to identify how outliers are and how we can use this interquartile range to identify the outliers as well.
Excuse me, sir.
Hello.
Sir, actually your voice was lagging a bit, so do you mind please repeating it?
Yeah, Akshita, sorry. Yeah. So what I was telling was this was the uh I had covered till percentile, right? Or up to where
So
you had.
after you put in that data, all of that was just a blur. So if you could please.
Okay, okay,
Thank you.
okay. So this is okay, okay. Okay. So this is what my data point was, right? So original data what we had was this. And what I did is I arranged that in an increasing order. Okay, ascending order. So this was what my original data was. And what I did was I arranged it in an increasing order. So this is 1, 1, 2, 3, 3, 5, 6, 7. So if I look into the central point or the central uh, median of the data, so that is coming to as 3. If I want to know where is my 10% of my data lying, so 10% of my data would lie below this. If I have certain data points and I take the first data point, or suppose I have 100 data points and take the 10th data point, which after arranging it in an increasing order, so below the 10 data point, whatever data is, and the 10 data point would give me the 10th percentile of my data. Similarly, I can calculate the 50th percentile and the 99th percentile as well. Okay. So if for this particular data, what I have, so the 10th percentile is 1, 50th or the median is 3, and 19th is 92. Given that I have got 100 and it is pulling my percentile value towards that number as well. So suppose say these are the marks scored by candidates in the CAT exam, right? And for particular say IMA, the 99th percentile is what we need for the particular uh, CAT score for people to admit into IIMA, right? So according to that, the 99th percentile, what it would come as 92.55. So any people who have scored more than 92.55 would be getting eligible to get into admitted into particular university. Who are less than that might not be eligible. So percentiles are mostly helpful in these cases where we have a set of numbers and we want to understand how and how is my population distributed and how are my data points distributed, and that would give me the skewness of the data, and that would give me how many people are lying within that particular population or the region. So without taking the 10th, 50th, and 99, if I take the 25, 50th, and the 75, that means dividing that into three zones or the four equal quarters, that is quarter one, quarter two, and quarter three. So that would give me the quartiles. These were the percentiles. So percentile can be any number from 0 to 100, and quartiles is the fixed number 25, 50, and 75. 50th quartile or the percentile would give me the median as well. Okay, so for that particular data set, what I have is the 25th percentile is 2, 50th is 3, and 75th is 6. And interquartile range. So interquartile range gives me the a sense of how much is my standard deviation of my data is. So if I take the difference between the third quartile and the second quartile, 6 minus 2, it is coming as 4. So 4 is the standard deviation of my particular data set. So more on this will understand and get a understanding of it and know the use of it as well while we are looking into how to identify outliers, how to deal with outliers, and all those things. Okay. Yeah. So coming into data distribution. So what is a data distribution, right? Suppose I arrange all my data points into a uh, chart or whatever we have and do a plot of my data point, and just to see like how my data looks like. Okay. So to get an understanding of how my data looks like and how what is the underlying distribution within my data. So the various central tendencies or the central uh, 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 measurements what we understood were like the mean, standard deviation, and the variance. Those are the crucial factors which can say that how is my data looking like. Is my mean or the central tendency of the average is near to zero, or how much are my standard deviations are being? Are they filling into a particular zone, or how is my data looking like if I plot it with the standard deviation, mean, and the variance? So one of the common data distribution what we have is the normal distribution or the Gaussian distribution. So that this is how a normal distribution would look like. So where mu or the uh, mean or the average is this, and this is one standard deviation mu minus sigma and mu plus sigma, and this is two standard deviation. If I took two data points or two standard deviation from the average, that is a two standard deviation, and any normal distribution, 68% of the data would fall within this, and 95% of the data would fall within this, and 99.7% of the data would fall within this particular distribution, particular values of any particular normal distribution. Okay. And the other kind of distribution would be the uniform distribution. So the examples of normal distribution can be the suppose say the height of the students in a particular class, right? So that would be like we know that on an average in an Indian scenario, the height normally falls within 168 to 170 centimeter for the male, and a less number as compared to the female. So if I arrange the height of the population and plot that, that would come as a normal distribution. Okay. And this is uniform distribution. So uniform distribution is something, if I plot that, that would be resulting in a flat and a constant distribution. So anything which is constant and which does not change as a lot. Hello.
Yes, sir.
Yes, sir, you audible.
Hello.
Yes, sir,
And the
you
other is
audible.
the exponential distribution. Okay, okay. And the other is the exponential distribution. So exponential distribution is the right skewed distribution. So this is a skewed distribution. This by skewness I mean that it is squeezed to one particular area. That can be right skewed or the left skewed. So if it is if it is left skewed, if it is right skewed, that corresponds to an exponential distribution, and it mostly corresponds to the suppose say the any event which is occurring say as drastic change or it is decreasing exponentially. So those kind of distributions are called as exponential distribution. So these were the examples of the some of the examples of the continuous variable, continuous data points what we have. And if I look into the discrete data points and plot them accordingly, so those can be categorized into binomial distribution and the other is the Poisson distribution. So that there are other distributions as well. For the interest of time, I had taken look into these two distributions. Okay. So binomial distribution tells us about the probability. So this is on the y-axis is nothing but the probability of the occurrence of any of the particular event in any of the specific Bernoulli trials. And the Poisson distribution is also a kind of a binomial distribution, but it is a skewed distribution. Okay. The other thing what we have is on the data summarization. Okay. So this I will be taking you through an example and giving you an example of how to do the analysis and how to find out the statistics of my particular data what we have. Suppose say this is the data set what we have, right? So using pandas, what I have created is a sample data for Indian students. Okay. So these are the name of the students what I have. These are their corresponding age, gender, city from where they are, their marks and their height in centimeter and the grade which they have scored in that particular subject. Okay. Print the data set would look like for anyone who was asking on when to use pandas, when to use numpy and all those things. So this is how you can use pandas. Okay. Using pandas, what I have done is these are individual set of data points. This was an array of data points and this was an array of data points. So using this, I have created a dictionary out of it. Using that dictionary, I have created a data frame. So for Rahul, who is of age 20 and a male from Delhi, he has scored 85 marks and is 170 centimeter and has scored grade A. Okay. So this is what my data looks like. And from this particular data set, what I want to look is, I just want to get an understanding of how is my data distributed? How are my data points looking like? So if I do this df.describe, which is an inbuilt functionality of pandas. So from this, it would give me for all those continuous variables which are there, like age, marks, and height. For each of this, it would say that how are my all those central tendencies or all of my descriptive statistics are. Okay. So count is 7. So 7 data points we are having. So 0 to 6 is 7 data points we are having for each. And the mean or the average for age is this much, for marks is this much. And this is the standard deviation. This is the minimum. This is the first quartile. Okay. This is the median. This is the third quartile. And this is the maximum of each of this. So with one snapshot, I can get an understanding of how well are my central tendencies or my descriptive statistics are distributed within my particular data set. From this, I can get an understanding of uh, how to use this particular data. Okay. And the next is I want to understand like how is my height different for male as compared to female. Okay. So what that I have done is I have done a group by on gender and then I took an aggregate of the height and I had taken the average of height. Okay. So if I do that, I would say that for male, the average height is 174 centimeter and for female, the average height is 164 centimeter from the data set what I have. Okay. And the other thing is if I want to calculate the median of my data set. Okay. So for every city wise, how are my data points distributed? So in Bangalore, the average age who have enrolled into my courses is 19, and the marks scored by them on an median is 78. In place of median, I can also do the average as well, like the mean, but to avoid like outliers and all, I had taken the median. Okay, so this is how city-wise my data points are looking like. Any questions still here?
So can you explain the group by function also?
Okay, okay. So what we do with group by is, suppose say I want to understand that, so these are categorical variables, like city is what? A categorical variable. So let me give you an understanding of what is a continuous variable and a categorical variable. So height is a continuous variable. So height cannot be a fixed number, right? In a population, so it cannot be a fixed number that my height would need to be this 170 centimeter or it need to be 165 centimeter. So height can be something like 170.1 or 170.8, 165.9, all those things. So these are continuous variables. But city would be a categorical variable that I only belong to Delhi, I only belong to Mumbai, I only belong to Bangalore, right? So by looking into the data, if I want to understand that how are my other data points, the other continuous data points or other categorical data points are dependent on my categorical variables. So to do that, what I do is a group by. So suppose say I want to do a group by on what grade, right? How are my with for every grade, how are my values looking like? So people who have scored A belong to the age of, on an average, belong to the age of 21. Okay, and their marks scored is on an average is 86.5. So this would give me a one complete overview on as how are my data points distributed on one particular categorical variable. Okay. So using this group by, one can do many analysis and many other things. So what I would say is get an understanding of this, and in the week through this, you would be having the code along thing. In that, you'd be having some of the examples you can pick up from there, and you can practice on your own. Okay. This is a basic understanding on basic example of how you can use group by I'm giving you. You can also play around that, look into how people have implemented, look around how people have done. Okay. Coming back to the next thing of so this was on the summary statistics with pandas, where we have looked into the describe, and the grouping and the aggregating data, where we had looked into the group by function and the aggregate functions. And the next thing is the data cleaning and preparation. I think we need to like make it fast. We have a lot of things to cover. So how to handle the missing values? So what are missing values, right? And what are the various imputation methods which are available? Like how can I fill up for my missing values in my particular data? And dropping the missing values, like when to drop or when not to drop. Okay. So let me give an example of that in our code as well. So this is the same data set what I was looking, I was giving an example to you for that particular data frame. And over there, you had seen that all of the data points were full, right? But over here, as you can see, there are some of the fields where there are nans, right? So nan is nothing but nulls. Nulls means that suppose say we were capturing the age of the particular patient, age of the particular students in a particular course, but somehow we missed that particular. So Ravi's age we have missed to fill into a particular data sheet. Okay. And similarly, while filling for the gender, we missed to fill Siddhant's gender. Or it can also be the case that Siddhant has deliberately missed his gender. He doesn't want to specify his gender. So all these things are called as missing values. Okay, wherever you see nan or the not a number, so those are missing values. And the best way to identify any of the missing value is what we do is we need to look into the particular data. First, we need to pick up the particular data frame. And from that particular data frame, we need to find out which are the nulls. How are my nulls looking like? Are there any nulls in the name column? Are there any nulls in the age column? Right. So this is how we need to look into the data and get an understanding of where is my missing values are. And then the other way is if we have got missing values, so one thing what we can do is, can somebody tell me like if in the name column, if I don't have person's name, what shall I do it over here? Is it wise to fill this with something random or to drop this particular row, or what shall I do?
Drop the.
Sir, we should drop it.
Okay.
Drop it.
And okay. And suppose say in the marks, okay, there is also an an over here. So what shall I do? Like, shall I drop it or
We
what
can
shall
use
I do?
zero, I guess.
We can use zero. Someone is saying like for
We
Sheena, we
can
know
use the
that.
mean.
Mean.
Okay. So why do we use mean? Say like there is also height also here. In the height there is also nan. As someone said, we can drop it or we can use the mean. Okay. See, the thing it comes with the underlying data assumption as well. So like in the case of height, we know that the height is generally falling within say 170 to 160, 160 to 170 range. Okay. And for male, what we had seen is for male, it is generally 174, and for female, it is generally 164. Okay. From this data point, we have got an idea that on an average, the height is within this particular range for male and female. So what we can do is within that, using that information for this particular data point for male, we knew that it was 174. So what we can do is, so wherever there is male, we can take an average of that and fill this with that particular number. So for this, we can fill this with 174. Okay. Hope you all are aligned. And similarly, like the other cases, like suppose a name. So name is a subjective thing. I don't know like what the name of a person would be. So in best cases, like which cases where the particular feature is an identifier of the data, in that case, what we do is we try to drop that particular this thing. So the best would be to drop this particular row. That means for this particular row, we have no idea that what is the name of this particular person. Where in cases like continuous variable, and we know that that can be imputed with some of the things which can be taken up from the other columns. In that case, we fill that with the imputation techniques. So there are various imputation techniques. One of the imputation technique is like filling with NA. So wherever there is fill NA is one of the function of pandas. Wherever there is NA, I can fill that with zero. So if I fill that with zero, so wherever there was null, it is coming as zero. Okay. And the other is I can fill that with the mean of that. Okay. I can take the average of that particular column and then fill that up. So as you can see in my height, there was for Ravi, there was a null. Okay. So what it had done is it had taken an average of the height and it had filled up with that particular number. So either you can do it that way or the other way can be take a group by and take an aggregate and do it vice versa. So what it does is with the if we impute with the mean, it continue in the cases of continuous variables, it can only work. In cases of categorical variables like the grade and the gender and the city, it will not work because the algorithm or the computer is not able to understand like what all these numbers mean. So in that cases, it is not able to impute. And the other thing how we can do the imputation is the forward fill. Okay. So suppose say we have got a time series data. As we know that this is how my data point would look like. Suppose say we have the, sorry, suppose say we have the daily or the daily maximum temperature of a city, right? So I have say for this is a 10 days data point. So I have 41, 38, 20, sorry, not 20, 38, 42, 44, and this is the missing value. Okay. And this I have got 45 and again 39, 37. Okay. So this is the daily temperature of my maximum temperature of a particular place in my city. Okay. But somehow for this particular day, I have missed is that particular data that on this day how much was the maximum temperature. So can anybody tell how fill this up? Hello.
Yes, sir, your
Hello.
voice was a bit unclear. Could you repeat your question, participants?
Yeah, so the thing is, what I'm saying is, suppose this is the set of maximum temperatures what I have for my particular city, and this is for every day I have collected the temperature of my place, right? So this is say it was 41 today, 41 on one day, 39 on another day. This is on every day I have got the set of maximum temperature at a particular place, but somehow I have missed this particular uh, recording on this particular day. So how can I fill this up? Can anybody tell me, like using the other imputation techniques what I have? So suppose this is a NA, this is a null. Okay. How can I fill this up? If I fill this with 0, df dot fill NA with 0, what it would say? It would give me as a 0, right? But my place temperature cannot be 0 at that point, right? So how to fill this up? Can
Probably
anybody
you
tell
So
me?
we can
probably
take
you
the average mean.
temperature. We can take the mean.
Yeah. Yeah. So one thing we can do is we can take an average of all these numbers and fill this up. And the other thing can be like, suppose say I know that most of my temperatures are dependent on the previous day's temperature. So 39 is dependent on the previous day's temperature. 38 is dependent on the previous day's temperature. So what I can do is do a forward fill. So what forward fill So sorry, I can do a backward fill. So what a backward fill does is it looks into the data and takes the corresponding value and fill this up. Okay, like it does this 44. And the other thing can be a backward fill. So what I have on this is 45. So my assumption is whatever data point is lying ahead, that would be the same thing. Okay, so this is like a backward fill. This can also be done. Or the other, as someone mentioned, is like a taking the average out of it. I can take an average out of it and fill that up. Okay, so these are the various ways how I can impute my data and use the central tendencies like the mean, median, mode, standard deviation, variance, all those things for my betterment purpose. So that this is how an example of in the data frame how I'm doing the fill NA and the method is forward fill. So for all the categorical and the continuous variables, what it does is it just looks into the particular data what this has. So for this particular candidate, we were not knowing what was the name of that particular candidate was. So what it had done is it had filled that with as Anjali. But this is completely wrong because Anjali is the name of a female. But given that it is already a male, it has done that as a given the name as his this. So this can be a bit controversial to use in the cases where we are dealing with the categorical data. But in the cases of continuous data where we know that the number can lie within a certain range or a particular range, so in that case the forward fill and backward fill can be helpful for you. Okay, so in this case like Siddhant was backfilled over here. And the other methods which are also available are like the interpolation techniques, as you might have understood, right? So the various interpolation techniques which are available, like the linear interpolation and quadratic interpolation. So where linear interpolation, what we do is we take the average of the data and we fill this up. And quadratic is we take a quadratic function and fill that particular value over here. So this is mostly useful in the case of continuous variables where we have. So if I go into the particular description of my this thing, so the method can be C over here, it can be linear. And there are other methods which are available, like uh, I can also fill this with the nearest neighbor also. So, and the other is the quadratic, the other is the spline, the other is the polynomial. So I can use different type of interpolation techniques and fill my data. So it depends on the use case as how to use, when to use linear interpolation, when to use quadratic interpolation, when to use the nearest interpolation. So nearest interpolation, what it does is it looks into the nearest data points and tries to fill that up. Whereas a linear interpolation, it tries to fill that up by looking to the previous and the current data point and take an average out of it. So this was what we covered on the missing values, and we also came to understand that how to identify any of the missing data point. And sometimes null also mean that it has been deliberately put as null. Okay, suppose say there is a in while filling up a particular data form, we know that someone can only fill male or a female, but in the other case, like in the case of a transgender, we are not sure like what to fill that up. So generally people fill that as a null. So null is also an identifier for the other genders as well. So it is also wiser for us like when to use what. If is it wise to drop that particular feature out of it, or use that particular feature, or how many data points are completely missing in my data? Is it wise to use all the data points or not? So those are the cases where it is useful. And in the imputation methods, we had looked at the mean, median, mode, forward fill, back fit, and the various interpolation techniques, and the dropping missing values, like when to drop the missing values and when not to drop. Okay. And coming to this thing is the dealing with outliers. Okay. So suppose if this is my data point, how it is looking like. This is how I have plotted. This is my x curve and this is the y-axis. And the data points which are far away from the average are considered as an outlier. So why are outliers necessary and why are the identification of outliers important? Okay. Suppose say I'm trying to build a predictive model, okay, which tries to predict that given my x-axis, what would be my y value would be. Okay. And given that, so this is a 1, this is 2, this is 3. So most of that is coming near to 2. And I have built that particular model out of it. But given this outlier, that would completely skew my particular distribution. It says that whatever model I would fit, that average would be skewed towards this. Because if I take an average out of it, it would be coming near to this. Okay, it would coming near to this. And if I take a median, it would be coming near to this. So sometimes it is wiser for us to identify the outlier and drop the outlier out of the data because if the outliers are quite small in number, it is and those are not affecting my model performance, I can definitely drop those outliers. So how to identify which is an outlier? Okay, so like visually one can do is like plot this and find out if that is really an outlier or not. But the thing is sometimes visually also it becomes difficult given that we have a vast number of data points and given that it is a 2D axis, right? X-axis and y-axis. So from this we can easily get to know like which are the outliers or not. But in practical terms, it becomes difficult for us. So there are different statistical computational techniques what we have for finding the outlier. So one thing is the interquartile range. So interquartile range, if you remember, we had already done this while calculating the percentiles and the quartiles. Okay. So interquartile range is the difference between the Q3 and the Q1. So if I remember, if you guys remember, what was Q3? If anybody can say.
75th percentile.
Hmm. Yeah, that's good. So Q3 is the 75th percentile and Q1 is the 25th percentile value. And the lower bound is anything which is 1.5 times of interquartile range. Q1 minus 1.5 times of the interquartile range is the lower bound. And the upper bound is Q3 or the quarter 3 plus 1.5 times of the interquartile range. Anything which is more than the upper bound and anything which is lower than the upper bound is generally considered as an outlier. Okay. More on this, we'll look into the code walkthrough as well. So the interquartile range is a robust measure of variability that is less affected by outliers and skewed data. Okay, so any of the skewed data what we have, any of the outliers what we have, so interquartile range can play a crucial role in finding the outliers over there. The other thing what we can do is, so this is one of the statistical measure what we can use. The other thing what we can do is if my data is normally distributed, if I know that my data has a normal distribution, from that also I can find out which of the data points are more than the particular threshold what I have. So for that, what we do is we calculate the Z score. So Z score is nothing but it is a value which is in terms of the deviation which is happening from the average. Okay. So if I have the particular data point and I calculate it from the average or the mean and divide it from the standard deviation, that would give me the Z score. So if the Z is equal to 0 for that particular data point, suppose I have 10 data points, for each of the data points, I will calculate the Z score. So if the Z is equal to 0 for that particular data point, then the data point is exactly on the mean. Okay. Suppose say, let's come to this. Okay. So this was the normal distribution what we had. So x minus mu. So x is say mu. Okay. So x is mu. Mu means the average of the particular data. So if the average of the data was 3 and that particular data point is also 3. So 3 minus 3 by standard deviation. So suppose the standard deviation was 1. 3 minus 3 by 1. So that is 0. So if it is 0, so we say that the data point is exactly on the average or exactly on the mean. Okay. If it is more than that, if z is greater than 0, then we say that the data point is above the mean. So if you remember that particular standard normal distribution what we have, if we calculate the z scores, we can say that where that particular data point is lying on that particular normal distribution. Okay. And z is less than 0, we say that the data point is less than the mean. If it is more than 2 or 3, if we take the absolute value of that particular data point, and if it is more than 2 or 3, then we say that it is more than 2 or 3 standard deviation out of the mean. Okay. So if it is more than 2 or 3, okay, where we were saying that 95 percentile of the data would lie within this. If it is more than this thing, that if it is lying within this tail and this tail, if I take an absolute of that, or if it is more than this, say third quartile, where 99.7 percentile of my data would lie, if it lies within the extreme ends of this scale, then I would say that those are the values where it is an outlier. Okay, so for normal distribution or for normalized data, we generally go with the Z-score technique, or the other thing what we already have in place is the interquartile range. Okay, so say this is the data set what we already have, right? This is how my data set is looking like. Same one where we had the 1000 over here. So any of the person who would be looking into this thing would say that the outlier is 1000. Okay. So from that, let's calculate the interquartile range. So for interquartile range, what we need is the first quartile, second quartile, and the third quartile. So the first quartile is coming this 2, median is 4, and the third is 6. Okay. And the interquartile range is 6 minus 2 is 4. Okay. Hello. Okay.
Yes, sir.
Yes, sir.
Yeah. And the lower bound would be, as we had already discussed, right? What was the lower bound? So the lower bound was Q1 minus 1.5 times of the interquartile range. So Q1 was what? Q1 was the quartile of 0. Q1 minus 1.5 times of the interquartile range. So interquartile range was Q3 minus Q1. Okay. That would give me the lower bound, and the upper bound would be Q3 plus 1.5 times of the interquartile range. Okay. So my lower bound was coming as -4 and the upper bound was coming as 12. Okay. So any data point which is less than this, less than the lower bound or more than the upper bound is considered to be an outlier. Okay. So what I have done is I have written a list comprehension over here, and from this I am finding the outliers. So using this, my model is saying that the outlier value is 1000. Okay, which is correctly identifying that yes, this is 1000. Okay. The other thing what I can do is by using the Z score. So for the Z score, what we need is x minus mu by standard deviation, where mu is the average. So for that, we first need to calculate the average, and mu is the standard deviation. Sorry, sigma is the standard deviation. We need to calculate the standard deviation of my data. Okay. So for each of my data point, what I'm doing is I'm subtracting that with the average and dividing that with the standard deviation. That gives me the Z scores. So if I do that, what it would give? Let's print this out. So I have got all these data points. So for each of the data point, what I have, let me print the data as well. So this was my data, and for each of the data point, I have got a individual data, sorry, Z scores. Okay, for each of the data points, I have got the Z scores. And anything which is more than 2 or 3 standard deviation is considered as an outlier. So let me keep this threshold as 2. Okay, and for each of the data point which is more than 2 or 3 standard deviation will be considered as an outlier. So if I print this, so it says that for all the Z scores which is more than 2 will be considered as a outlier. So over here 1000 is coming as an outlier. So if I keep that as 3, okay. So for 3, this is not considered as an outlier because it is not lying at the extreme tails of the particular normal distribution. So for this, what we need to do is we need to always have to find out what is the threshold for this. So either the best thing is to keep it to 2, and from that we can find out like, yes, if this particular data point is more than standard deviation, 2 standard deviation, then yes, this is an outlier. Any questions till now?
Sir, to our data, if we add 2000, 3000, and let's say 4000, then what will be the outliers? How will it change?
Okay, okay. Yeah. So as someone mentioned, we can add 2000, 3000. Okay. This is fine, right? Or another number you want to add?
Yeah, one more if it is okay.
Okay. So we have added 4 numbers. Okay, 4 numbers which are in the 1000 ranges. In total, we have got 11 numbers and 4 are in 1000 ranges. So let's see how my interquartile range is coming up. So still my interquartile range is coming in this particular range. So IQR is coming as 1247 and the lower bound is coming as, yes, it's still the same what we had, right? And let's calculate the Z score as well. So from this, it is saying that 4000 is an outlier. So if I make this as 3, will this be considered? So no, it is not considered. So from this particular range, what we see that 4000 is like 4 times more than the interquartile range. So the interquartile range was coming as 1250, 1247. So it is more than say 3 times or 4 times, near to 4 times of the interquartile range. So near to 3 times the standard deviation, it is more than that. So it is considered as an outlier. Okay. So you can also play around with this as how the outliers is coming and if those outliers are meaningful to me or not, or if it is truly wise to drop those outliers from my model. Okay. So let's come to the other thing is the data transformation. So there are various data transformation techniques what we have, and the one of the main need or the use of data transformation is to maintain consistency in my data. Okay. Suppose say I have got a data set and in which one feature could be in dollars and the other could be in inches, right? Suppose say I have got a set of uh, data points in which it has got the average earning of a particular person in a city. That would be in a dollar. But the other is like how many, like what is this shirt size of the particular person? So that could be in the inches. So both of these are incomparable to each other. So what we do is to make those comparable. So dollars would be like say it would be in say 0 to 1000 ranges, but in the shirt size could be within say 30 to 50 inches. So to make them into one particular scale and to make them comparable to each other, what we do is we do data transformation. And the other thing is various machine learning techniques and various algorithms what we have, like the linear regression, neural network, and all those things. They are mostly parametric models. That means they are best suited for the data points which are uh, which have a normal distribution. The gradient descent and all those things, which we will be discussing in our subsequent discussions. There, it is best wiser if we can transform our data into normal distribution. And like some of the algorithmic distance-based algorithms, like the k nearest neighbors and the k means, they are dependent on the distance matrices. So for distance matrices, it's also like if those are of different scales, then that would give us a different picture. So to make an uniformity within the data, what we do is we make them into, say, a min max scalar uh, or a 0 1 scalar kind of a thing. And the yeah, so this is normalization and standardization. So normalization is the process in which we are trying to convert the data point within a particular range of 0 to 1. So this is how a normalization is done. So normalization or the rescaling, what we say in other words, is the mean max normalization. So where x is my original value and mean of x is the minimum of the value and maximum is the maximum of the data point which is available, x minus mean by max minus mean. Okay, so this would give me the particular data point which is arranged in the 0 to 1 range. And the other thing I want to do is if I want to convert that into a standard normal distribution is to do into a standardization technique. So where we the same formula what we have done for the same thing. So where we divide that where we difference of the data point from the mean and take a division with the standard deviation. So this would give me a value which is between the 0 to 1 and also like of a mean of 0 and a standard deviation of 1. Okay. And the other techniques like the log transformation. Okay. So log transformation is data transformation technique that can be applied to highly skewed data. Suppose my data distribution is looking like this. If I take a log of the data, like np.log, so it would make into a normal distribution. If I, on a normal distribution, if I took an exponential of this, as you know, right, most of the people you know, like log and exponential are opposite to each other. If I take an exponential on this, so it would make it into the original format, like the skewed, right, skewed data. So this is mostly useful in the cases like where we have a long tail of data. Like suppose say this is the average sales of a particular smartphone in the market. And I know, right, some of the smartphones are sold the most, like iPhone, OnePlus, and all those things. Suppose say coming to some of the not so popular brands, like say Lava or some of the Indian brands, right? So they would be having a long tail distribution. That means the number of sales would be quite low as compared to the number of sales which is happening for OnePlus or iPhone or Apple. So to make that into a normal distribution, what we do is we take a log on top of it and make it into a normal distribution. So let's look into this, how we can do this. So this is the data set what we had already. And on this, what we are trying to do is for the columns like the age, mark, and height, age, marks, and height, what we are trying to do is we are trying to do a min max scalar. So min max scalar is nothing but is the difference between the minimum of the particular value divided by the maximum minus minimum. So it would make that value into 0 to 1. Okay. So for age, marks, and height, so age, which was something in the range of 2019, 22. So I have made that into 0 to 1 range. Similarly for height and similarly for marks as well. I have made that into one particular range. And the other thing is the standardization. So which is the z-score standardization. So if I want to make this into a normal distribution, I can do is this thing. So already have the standard scalar. So this, if you would say like from where I have got that, so this is coming under a package which is called as sklearn. Sklearn is the scikit-learn, which is a package available in Python. So under this scikit-learn preprocessing, these are the available min, max scalar and standard scalar. Okay. So using standard scalar, I have done a transformation on top of it, and it has made this into a normal distribution, standard normal distribution. Okay. Value lying between -1 to +1 and like 0 being the mean and less than 0 is the what is z score of less than 0 and more than z score of is positive values. And let's come to the other thing. If I have got categorical values, so how can I use that and how can I use them in my particular modeling technique? So for using the categorical values, one way is to use the label encoding. The other is the one hot encoding and ordinal encoding and target encoding. Suppose I have got categorical values, as I have already mentioned, right? My model is unable to understand like what all this means. Like if there is a column called as color, which is red, green, blue, and all those things. So my model is unable to interpret like how to use the red keyword in my model. So what I can do is if I say that 0 is equal to red and 1 is equal to green and 2 is equal to blue. So anywhere it sees red, it would fill that as 0. Anywhere it sees green is 1 and anywhere it sees blue as 2. Okay, so this is what is called as label encoding. And the other thing is one hot encoding. So one hot encoding is nothing but if I arrange it in this particular fashion. So for red it is 100 and blue is a 010. Okay, and green is a 001. So wherever it sees red, it should be 100. So in this fashion I am making three different columns. So for color red, it is 1, color blue, wherever it is color blue, it is 1, and wherever it is color green, it is 1. Okay. So this is how I can make this into one hot encoding. So in one hot encoding, what we do is we are expanding the number of features into the number of categorical variables that I have. The number of colors that I have, that many number of extra features would be coming up. And the other is ordinal encoding. Suppose say I already know that poor is different as compared to good and very good is different as compared to good and poor and all those things where I know that there is a clear distinction between the encoded values. In that case, for my model to know, I can fill that up with the numbers I have. Okay, where if I know that poor is 1, good is 2, very good is 3, and excellent is 4. I have known that this is in the particular order or in the ordinal number this needs to occur. And the other thing can be target encoding, where in the target encoding, what we do is we look into the target like wherever there is cat. So cat is occurring 1, 2, 3, 4, 5. 5 times it is occurring out of 9. So what we do is wherever there is cat, we replace that with 5 by 9. Okay, so that would be this much. And wherever there is hamster, so how many times hamster is occurring, we fill that up with that particular number. So this is how we use the target value to encode our original categorical value. So let's look at an example of how we can do the categorical encoding. This is the data frame which we already had.
Hello. Sir, a question.
Yeah.
So what if we have large number of categories uh, like if we have names of city and
Mm-hmm.
we can choose any name from worldwide.
Yeah. Yeah. See, the thing is, if that is meaningful to me, if that is really helpful for me, suppose say in Indian cities, what I'm using, right? I know, right? Indian cities can be a clear distinction between this number to this number. So I can also do that as a label encoding, or I can also do that as a one hot encoding. If those are clearly too much in number, and if those versus some of the cities like say tier 3 cities where from there the population would be quite less and the number of data points what I am getting is quite less, so it is better not to use that particular city. I can drop that particular city as well.
Thank you, sir.
Yeah, so this is original data frame what we had, and over here what I'm doing is label encoder. So this is the same from sklearn scikit-learn pre-processing. I have taken the label encoder and the one hot encoder, and there is another package called as category encoder from where I have taken over that. So in the label encoder, what I have done is wherever there is a male or a female, I am converting that into another number. or a value for my model to understand. So label encoder, if you remember, this was this thing. This was the label encoder where I know that for red it would be 0 and green it would be 1, like a clear mapping I have. So for gender, what I have done is I have done a label encoding. So wherever there is a male, given that my model has already understood, it is making wherever there is a male, it is making that as 1, and wherever there is a female, it is making that as 0. Okay. And the other thing is one hot. So one order is the another way of representing my data. So if I want to transform my city data, so for city data, wherever the city data is, I want to transform that into a one hot encoded value, right? So for on that particular data frame, what I have done is I have made that as one hot encoded. So this is coming as individual features over here. So for this particular people like Rahul, he belongs to Delhi. So for city Delhi, it would be 1. For Sneha, I think she belongs to Mumbai. So for Mumbai, it would be 1. Rest would be 0. So this is how you can represent your data over here. So this is one hot encoding. The different encoding and the label encoding is, if you would see, if I would have done one hot columns, one would be the gender male and gender female, and either 1001 that would be there. But over here, in the case of one hot encoding, this is how it is done. So the main difference between label encoding and one-hot encoding is if I have a large number of data points, then it would exponentially increase my number of features what I have. As someone was asking, if I have a large number of cities, then that would also increase my number of features. So in that case, the best way to do is we can go with label encoding techniques where the number of like the categories are too much. And this is the ordinal encoding. So for ordinal encoding, if you remember, this was ordinal encoding. For poor, I know that it should be 1, good is 2, very good is 3. So I have created a mapping out of it that A plus is 1, A is 2, B plus is 4, A minus is 3, B minus is 5. So this is the mapping what I have done. So wherever it sees this particular gradation, it will try to fill that up with the particular value what I have for my model to understand. So this is like human intelligence where we are feeding into my particular model because my model does not know like what are these grade means, how are Indian students graded versus the European students and all those things. So for this, for the people, like the grade has been changed over here. So wherever there was A plus or A minus, it made into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And the other thing is target encoding. So target encoding, like suppose say I have got a target that a column which says that the status of the particular people, whether the particular person has passed or has failed. So 1 means that the person has passed and 0 means that the person has failed. So how can I use that particular value to encode my underlying categorical values? So over here, what I have done is I think there is some, okay, sorry. Okay. Using the status column, sorry for the typo, this was status I have mistyped as TS. So using the status column, I am encoding my target column, which is my gender. So wherever there is a gender male or female, based on this thing, it is trying to replace that with the status that I have. So wherever there is a male, so for the people who have passed, and it is male, the number of times it is offering. So it is trying to impute that with the particular average value out of it. So 0.72 is for male and I think 0.70 is for female. So this is how we can use the target encoding for my particular use case. Okay. Any questions till now? I'm audible, right?
Yes, sir.
Yes, you are audible.
Yes, sir.
Okay, yeah. So coming to the last leg of this lecture for today is on the data visualization. Okay, I think we have taken a lot of time, so let's quickly wrap this up as well. So data visualization. Okay, so data visualization can be divided into three parts. One is the univariate analysis, the other is the bivariate analysis, the third is the multivariate analysis. So under univariate analysis, what we have is the histogram. So this is what you have most of the people who have studied, like had got maths or have looked into the data would have looked into this kind of a plot. Can anybody tell me what is the difference between a histogram and a bar plot? Hello.
Histogram is for continuous data and bar plot is for discrete data set.
Okay, so in histogram, what we calculate?
Frequency, sir.
Okay, so it is like self-explanatory over here. No prize for answering. So histogram is mostly used for continuous data. So any of the continuous data what we have, suppose we have got collected the height of all the people in the particular session what we have for today. And from that we want to understand like how the height is varying across different uh, how the height is varying. So if I take a bin of it, so 135 to 140 is one bin and 140 to 145 is another bin. So every five data points of bin I have taken. And within that data point, any person who is falling between 135 to 140 is considered under this bin. So under this bin, there are two people. Okay. And 140 to 145 under this population or under this height, there are five people. So that is how I can plot that and give that a visual structure out of it. So that this is how I can plot and look into the continuous data what I have. But for the cases like for the categorical data what I have, right? So people who have scored X number in chemistry or people who have scored Y number in chemistry, right? So what is the average mark or average uh, number of people who have got Nobel Prize in particular subject in chemistry or physics or literature or medicine? So if I want to do a categorical level analysis, in that case, bar plot is necessary. So in chemistry, say I know that 180 people have got uh, Nobel Prize, and in physics, 210 people have got Nobel Prize. So this is used for categorical variables, while this is used for continuous variables. So in continuous variables, we make them into bins and plot them accordingly. But in categorical variables, we just take a frequency out of it and just take a count of it, and then we can plot that into a bar plot. Okay. The other is the box plot. The box plot is nothing but what we have looked into the quartiles and the percentiles wherever we saw that what are the different values Q1, Q2, Q3, and how can I plot that into a box and a whisker plot. Okay, so that from this I can get an understanding as where my outliers are and where my standard deviation is and where my median of the particular data is. So this is how a box plot would look like, and this is the quarter one and this is quarter two, so this is quarter three, and this is how my maximum and the minimum would be. It helps in visualizing the spread and the skewness of the data as well as identifying the outliers. So let's look an example of how we can do that. Coming back to the same this thing of the particular data set what we have. So this is how my data frame was. Okay. From this, I wanted to understand for each of the particular age, mark, and height, how my histogram would be. Okay. So what I have done is using matplotlib, I have plotted this. And what I have done is I have taken a bin of 10. Okay. If you remember in the height example, was taking a bin of 5. Okay. And here I was taking a bin of 10. That means there would be 10 different bins. And for age, this is how my frequency is. So within 19 to 19.4, there are two people. And within 20 to this much, there are two people. So this is an histogram of the underlying data what I have. So for marks also, like within 55 to 63, two people have scored, and within 75 to 85, this many people have scored. So by visually looking into the data point, I can tell about how my data is looking like. So suppose I have got a big data, that means there are more than say thousand or lakh records over here. I can just go over data or do a group by operation or an aggregate operation. By looking into this kind of a plot, I can get an understanding of how my data is looking like. Okay, similarly for height also. So for the height, what I'm saying is 160 to 175, this many people are there, and all those things. And this is for the categorical data. So if you remember, there was the categorical data, that was the gender and the grade. So for gender, what I am saying is there are four males and three females. So this is a box. So this is a bar plot, and this is a histogram. And this is for grade. Like in A, this many people have scored A plus, this many people have scored. So by looking into the data, so I have used Seaborn as a library. So you can use matplotlib as well. So using Seaborn, what I have done is Seaborn dot count plot. And over here for histogram, what I have done is plot dot hist. So matplotlib has been imported as PLT, and plot dot hist gives me a histogram out of it. And this is how my box plot would look like. So box plot, if you remember, this was the, what was this one? Can anybody say what is 20 over here? Which is the Q1, Q2, Q3 max and the mean?
Sir, 19 is min, 23 is max, and
Hmm.
19.5 is 25th, and 20 is 50th, and
Okay.
21.5 75th.
Okay. 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 Very good. And what would be the interquartile range over here? IQR?
21.5 minus 19.5.
Yeah, yeah, that's very good. So that is how we can look into the data point. So for age, what I'm looking is I have done a box plot over here. And if I say that anything which is more than 1.5 times of the interquartile range, right? Q1 plus, sorry, Q3, so 21.5 plus 1.5 times of the interquartile range. So interquartile range was coming as 2, right? 21.5 minus 19.5. 2 into 1.5, that is 3. 3 plus 21.5 is 24.5. So anything which is coming more than the maximum, that is more than 24.5, is considered as an outlier. And similarly, anything which is coming less than 18 would be considered as an outlier. So box plot would be helpful for me to consider or to visualize how my data looks like, and where my outliers would be, and how my data is skewed. Here you can see that the data is mostly skewed or left skewed towards the this much, towards 19 or 20. And in marks, it is mostly right skewed towards 85. And over here for height, what you can see is the height is mostly not that skewed. It is mostly within this particular range, within 167 to 173, within 170. Okay, hope this is clear for you and would be helpful for you while you are looking into the data or analyzing the data. So for box plot, what I have done is same, the Seaborn I had taken. Seaborn is a library, sns.boxplot. And coming to the next thing is bivariate analysis. So bivariate analysis, there what we saw is univariate analysis. So univariate analysis, what we do is uni means self or one, where we are looking into the distribution of the data with itself. And in bivariate analysis, what we do is we look into the data or the how it is varying as compared to the other data points in the data. Suppose this is the ice cream sales of a particular brand in a particular city. So as I can see that as my temperature is increasing in a particular city, so is my sales of ice cream is increasing in my particular city. So this is how I can plot between the temperature and the sales. So if I would have done only for sales, and that would give me a different picture, and compared to temperature, that would give a different picture. So if I merge them on each other, a scatter plot would give me this picture, that how my temperature rise or decrease would drive my sales of ice cream. Okay. And the other is the line plot. So line plot is a plot that displays the data points connected by straight lines. So it is mostly used to identify the trends and patterns over time. Okay, suppose there is a recent movie which is coming up. So how is the trend going on? So how many people are currently watching as compared to today, as compared to day before, as compared to day before yesterday? How is the trend going? Is that increasing or is it decreasing? So for that, what we do is we take a line plot. So line plot is where the x-axis is the time axis and the y plot is the frequency or the mean median mode or the average count of it, all those things. And a heat map is also used where we want to analyze the distribution within two different variables. So this is also a bivariate analysis. Suppose say I want to understand how is my visit to a particular site occurring as compared to the hour of the day and the day of the week. So I can see that in the first hour, that in between 1 a.m. to 2 a.m., this many numbers are coming, which is in my range. This is quite low, 0, and high is 4. So by doing a gradient of it, or by looking at the color gradient, I could say that how at which point of time or at which day of the time or day of the week, and in that particular in Monday, at which time are my site visit the highest. So this is how I can plot that and get an understanding of my total underlying data what I have. Okay. So on that particular data set what we had, so on say the particular data set, I want to look like how my age and marks are correlated to each other, right? So for age and marks, so people who are the age of 19 are scoring in this particular range. They have scored in, one has scored in 64, the other has scored in this 76. So as the age of 21, people have scored this many number, and who is at the age of 23 is scoring this much. So that would give me a underlying assumption as how with age my marks is varying. And similarly, height with marks. So people who have got more height, is that corresponding to them scoring less or more, or people who have got the average height, are they scoring less or more? So within using this kind of analysis, it would give me an overall idea about my underlying data. And similarly, this is a heat map. So for this, I have used the matplotlib for plotting the scatter plot. And for this heat map also, I have done a matplotlib and histogram 2D. So here you can see like height and marks. So for height and marks, so this count where the color, if it is dark blue, the count is highest. If it is near to yellow, the count is lowest. So people who have like within this range, from this also we had seen, right? People within this range are scoring the highest. The count is highest. So 2 is here. And under this it is 2. And under this is highest. That is also represented in this way using the histogram plot. The other thing is the pair plot, like multivariate analysis, where we want to understand like if I have got different or more data what we have, how are they related to each other? Like suppose say this is one classic example of the data what we mostly use, the uh, iris data set. This is a flower for which we have the petal length, petal width, sepal length, sepal width. And I want to see how sepal length and sepal width are related to each other. Okay. And also the underlying data distribution is for each of the data points. So for this, I can do a multivariate analysis. A pair plot would give me this particular picture out of it. And coming to the last thing, what we have is the correlation matrices. So correlation is nothing but to understand how my two variables are related to each other. Okay, correlation is statistical measure that describes the strength and the direction of a relationship between two variables. So there are two different types of correlation. One is the Pearson correlation, the other is the Spearman correlation. The difference between the Spearman correlation and the Pearson correlation is, in Spearman correlation we consider the monotonicity. That means it is strictly increasing. If two of the curves are strictly increasing and those are positive, then the Spearman correlation is positive. But in Pearson correlation, even if it gives us a positive number or a negative number, from that we can understand that yes, those are increasing, but those might not be monotonically increasing or might not be monotonically decreasing as well. And what we do is we plot a correlation matrix, and from that we can get to know like what is the particular value out of it. And the range can go between -1 to 1. Okay. So this is how a correlation matrix would look like. So suppose say I have got like for public health data, I want to look like how they are correlated to each other. Like more connectivity gives users to more internet, and use human capital is more than connectivity is more. Is that vice versa or not? So if you see the diagonal thing, so with itself, the correlation would always be 1. Okay. But with cross, so this digital public services with connectivity is 0.64. So the same thing would be coming over here also. Connectivity with digital public services. This should give me an understanding of how my underlying data point are correlated to each other. Let's see in this term. So this is how you can plot a pairwise plot. So this is a pairwise plot of the age and the marks what we had populated. Age, mark, and height. So marks and age are, if I do a scatter plot, that would look like this. And height and age, if I do a scatter plot, this would look like this. And for the particular age, under the age, there are different bins, right? If you remember, there are different 4 or 5 different bins what we had. So how the underlying distribution is for age. Similarly for marks, how the underlying underlying bins distribution is. Similarly for height. Okay. And this is the correlation matrix. Suppose say I want to do the correlation matrix for age, marks, and height. So if I would see, it is coming as negative 0.19, which would say that age and mark are negatively correlated to each other, and age and height are negatively correlated to each other, negative 0.08. Like if height increases, like this is saying that age is decreasing, given that the data is not that perfect, but it should be the opposite way around. And similarly, mark also. Most of these are negatively correlated. This is what correlation with itself. Okay. So this brings to the end of the lecture for today. Any questions? Anyone?
Sir, could you please provide of the session?
Sorry. Hello. 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 Am I
Hello.
audible? Yeah,
Can you please
Harshita.
provide the
Yes, sir,
recording
you
of
are.
the session? Okay, thank you, sir.
Yeah.
Yes, we will be providing the recording of this question, this session. So the session has been recorded, and the link for the recording will be sent in the Discord server soon.
Yeah. Anyone else has any question? Hello.
No, sir, no
Sir,
questions.
sir, like, will you share the PPT also?
Okay. Yeah, I will.
Thank you,
I
sir.
will share.
And notebook
Yeah.
too.
Notebook also. Okay. Okay. I'll share that to Ayush. I think he can pass it on to you on the Discord server.
Sure, sir.
Okay. So what I would say is, given that I have, in the interest of time of 2 hours, yeah, Pratik. Hello.
Hello, am I audible?
Yeah, Pratik. Yeah, I can hear you.
Sir, can you explain the pair plot again with some examples on how different images are related to each other, different graphs we saw?
Okay. Can you see the screen?
Yes.
Yeah, see the pair plot is mostly used where we want to do a bivariate analysis, okay? Where I want to understand as how much my age is related to marks and height as well as the same time how underlying data within itself. Okay. Suppose let's take this example of height. Okay. So height with age, for age of this much, my height was this. If I do a scatter plot of this, this would give me a visualization of age versus height. Okay. And height versus marks, if I do a scatter plot, this would give me a understanding like this, the scatter plot. And under the height, if I want to do a distribution that for my height, people who are between 165 to 161 centimeter, how many people are there? So given that this is not labeled, so suppose that this is 1 and this is 2. Okay. So 2 people are there under 162 this much centimeter, and within this to this 3 people are there, 333. So this is a, what they have done is they have normalized this and put this into a normalized number, the mean max scalar what we had seen, right?
Okay.
Yeah.
But why
So
did
this
they
would
do that? Like, why did they not?
to make it into uniform scale, so that given that we are plotting it in different way, right? So this scale for height, it can go, say the count can go from 0 to say 1000. So for 0 to 1000 the scale would be different for this particular curve, but for marks the scale would be something different. So to make it into uniform, what we have done is we have normalized that.
And in multivariate analysis, the first one, the flower one.
Multivariate analysis, which one? The correlation matrix or
No, no, the flower
flower
model.
one? Okay.
And settle.
Okay, this one, right?
Yes.
Yeah. So
What
this is the
exactly?
same. Yeah, so this is the same thing. So for this example, if you remember, so for the particular species, there are three things: Setosa, versicolor, and virginica. So there are three different categories which are there for a particular flower. Okay. And so the red one is the distribution for this, and the green one is the distribution for this, and blue for virginica. Okay. So for different categories, so this is how my distribution would be. And for if I do a scatter plot between sepal width and sepal length, so this is how my distribution would be. The number of, for the species belonging to the red color Setosa, the width is this much and the number is this much.
Okay.
Yeah. So the more like you practice, the more like you get a deep dive. You can create your own data. Like I am passing on you guys my notebook as well. The more you practice, the more you understand, the more you would be having a detailed understanding out of it. As why, when to use univariate analysis, when to use bivariate analysis, when to use multivariate analysis, and which plots shall I use.
So pair plot is basically like a matrix of different kind of like
Yeah,
bivariate
exactly.
analysis.
Yeah, exactly.
Okay. Thank you.
It's not a bivariate. It's if there are two categorical variables, then only like it would be bivariate analysis. If there are if there are two continuous variables,
It's
it's
a
a bivariate
matrix, right?
analysis.
In the matrix, it has various bivariate graphs.
Uh,
The individual graph is still bivariate though.
yeah. It's a one-on-one, so bivariate, but overall it's a multivariate.
Yeah, yeah. Thank you.
Anyone else? Yeah, Mohit. The thumbs up was for okay, or you have question, or all clear?
So no doubts. Okay.
Okay, Harshita.
Clear, sir.
Okay, fine. Yeah. Okay, then if there are no more questions, we can end this call. I will pass on this sessions, all these things back to you. And if there are any questions, also feel free to like put this on the like your way of communication, and I can take this up in our next session as well.
Okay,
Okay,
if we
then
don't have
Arish.
any further questions, yeah, yes, so sure. Like if we don't have any further questions, then we can close this session here. Thanks a lot for this session today, sir. See you tomorrow.
No. Yeah, sure. Have a good evening, guys. Bye.